Hi folks, let's take a look at this last example of graphing reciprocal functions. And we notice here that we've got something a little different because our reciprocal is not the reciprocal of a polynomial. It happens to be the reciprocal of a square root function. But guess what? We're going to follow the exact same procedures. Now, the first thing to remember is that this function is only defined for x greater than or equal to 0. So I'm going to start by putting my y-axis way to the left. Okay. And of course, it's only going to produce positive values of y. So again, I'll put my x-axis further down. Okay, and I think what I'll do is I'll keep it simple and keep everything going up by 1, both on the numerator and denominator. Sorry, both on the x-axis and y-axis. I guess we're talking about fractions here, or rational expressions. Okay, so we've got 0, 0. We've got 1, 1, and let's go to 4, 2. Okay, and I think that's as far as we're going to go. 3 points is enough, and let's try to draw a nice. There we go. We know we're not going to quite reach 3 since we don't get to 9 here. Okay, so this is our original function. Let's see if we can figure out what our reciprocal function is going to look like. So the first thing you realize is that, well, the domain, any restrictions on the domain of the original function will affect the reciprocal function. Because if root x is not defined, then 1 over root x won't be defined at those values. Okay, so let's start at the x-intercept. There's only one x-intercept, and I think we've seen this now a few times. What's going on here? We see that the y values of my original function are positive and getting smaller and smaller and smaller. So the reciprocals are still going to be positive, but they're going to be getting larger and larger and larger. So it looks as though we've got a vertical asymptote at x equals 0, even though it's only on one side. Okay, let's look at the end behavior of this function. Well, here, as x gets larger, the y values are also getting larger. So when I take reciprocals of large positive numbers, I get small positive numbers. So we have end behavior that looks like this. Okay, and are there any invariant points? Well, I see there's only one value where they're going to share the same y value. When x is equal to 1, the y value here is equal to 1, and so the y value of the reciprocal is also going to be equal to 1. Okay, and from there we can determine that the graph is going to look something like this. Okay, and so that's what the reciprocal of the square root function looks like. Okay, so make sure you check out all the graphs that we did on Desmos to see how close you came. Okay, and we'll do a recap in the last video.